In this video, we're going to construct a box plot. The first thing we need to know to construct a box plot is we have to have the 5-number summary. We're using the same data set that we've been using all along this week, so we've already found the 5-number summary, so we go on to step 2, which is finding the range of that data set. The range is basically the maximum minus the minimum, so our highest number in the list was 75, our lowest number is 62.5, which gives us a range of 12.5. In step 3, we're going to use that 12.5 to determine the scale that we need to set for our box plot. That scale needs to be large enough that you can actually see all the numbers without having things to be too crowded, and if possible, we try to not use decimals. Ours happens to work out very well that we can set 1 unit on the graph to be equal to 1/2 inch, so that we don't have to worry about having decimals and trying to figure out the line spacing. In step 4, we're going to mark those 5 numbers on the graph. So 62.5 was already our minimum, 75 was already our maximum. The 67.5, which was our lower quartile, 68 was our median, and then 71.5 is our upper quartile. So we marked all of those, and then in step 5, we're going to draw the box that connects the lower and upper quartiles. This in itself, if you're asked to construct a box plot, this is everything that you need to do. But we are going to look at a couple steps beyond that, because we don't just need to construct the box plot, we need to understand that box plot. So in step 6, we're going to interpret. So for example, the box itself contains 50% of the data. So half of the numbers in our list are between 67.5 and 71.5, which obviously means that the other half of our data is outside that range. We can also say that that small little gap there between the 67.5 and the 68, that obviously contains 25% of our data, because that's what the box plot does for us. It breaks it up into groups of 4. So 62.5 to 67.5 is 25% of the data. 67.5 to 68 is 25%. 68 to 71.5 is another 25%. And then finally 71.5 to 75 is our last 25%. Then in step 7, we're going to look for outliers. And to find an outlier, we're going to use that box and figure out the interquartile range, and then add that number, or 1.5 times that number, to each end of the box. So to find our interquartile range, that's just the upper minus the lower, which gives us a range of 4. And then the lower number, 67.5, minus 1.5 times 4, gives us a low number of 61.5. Doing the same thing on the upper end, we're going to add. So the upper number, the 71.5, the top of the box, plus 1.5 times 4, which is our interquartile range, gives us an upper number of 77.5. We kind of consider those to be sort of like brackets. So anything from 61.5 to 77.5, we would say those are just normal data. Anything outside of that, we would consider to be an outlier. In this particular set of data, our lowest number is 62.5, which falls within our brackets, and our upper number is 75, which falls within our brackets. So we can say in this set of data that we have no outliers. Several times that we will find that there are outliers, and we usually indicate those with a star that extends on the outside of that, and we'll look at one of those later on next week.